Hello, and let's puzzle it up with a test, and let's see how this goes. I'm not quite sure, to be honest. So we got the test that you wrote this year, and see if we can just go through it again to remind ourselves how to get into each question. So the first question: simplify each of the following without using a calculator. So are you going to use a calculator? Well, of course you're going to use a calculator. So there we have it ready to use because we're definitely going to use it. But I'm also just enjoying having the toggle button. So we have our question here without using our calculator that we are going to use at some stage, and we can always punch it into our calculator to see what our answer would be. But let's not do that yet, because maybe we don't get that and it confuses us. So my first question is, we've got a binomial, in other words something with two terms, times another binomial. So another example would be like x plus 1 times x plus 2. How do you multiply a binomial by a binomial? Okay, so I'm hoping that you remembered, you went x times x, x times 2, 1 times x, 1 times 2, however you thought about doing that. So let's do the same strategy here. So you're going to go this times this times this, and then that times that, and that times that. And you're going to work through it from there, and we're just trying to get into each question, and let's see if we can pinpoint anything within that. Okay, next one. Rationalize the denominator after simplifying. What does it mean to rationalize the denominator? Well, rationalizing means that, in my books at least, it doesn't have this surd thing. I don't know how you would have put it, but it doesn't have the square rooty bit, right? So your number at the bottom is going to be like 3, not square root 4 would be a terrible example, square root 5. You know, yes, rational, irrational. Just relates to rational numbers. Remember we did those in grade 9. Okay, so how are we going to rationalize the denominator after simplifying? What strategies do we have to solve this question? Okay, and we could multiply it, but I think it's easiest to have your calculator handy and go, well, square root 63, so we just go square root 63, that's 3 root 7. So this bit here you could write as 3 square root 7 minus square root 28. Square root 28 is 2 square root 7. Okay, what jumps out at you that looks like you could do on the denominator? Well, I see common things here, so I start thinking factorize. Not always going to be the case, but definitely useful. Oh, it looks like you could take out a square root 7, 3 minus 2 is 1, or you've got 3 of these minus 2 of them, you've got 1 of them, you've just got square root 7. Okay, so you got square root 7 on the denominator. That was exciting. But you needed to show how you got there. Then you got 14. How are you going to rationalize the denominator? Well, maybe that's what you're still asking. You're going, I don't know. Well, in this case, just multiply it by 1, but a very special version of 1, because root 7 times root 7 just gives you 7. Now you've got a rational denominator. And the top 14 root 7, or whatever that happens to be, done. Okay, so next question, happily onwards. Square root x to the 4 times x to the 4. Okay, so we're testing, maybe here's a good question. How many terms are there in the numerator? Well, we don't know how to go. There's just 1. How many terms on the bottom? Well, also just 1. So we don't have to think about factorizing. And let's jump ahead and look at question D. How many terms in the numerator of question D? Well, there are 2, so we immediately jumping ahead, we know we're going to have to factorize over there. So we've got this square root of something to the 4. What does that even mean? Well, you can think of this in 2 ways. Well, let's do it. A square root is the same as a fraction. So the square root of x we could also write as x to the power of a fraction. What would that fraction be? Well, it would be a half. So we've got a half. So therefore, if we do that to the 4, we can do that to the 4. What do we do with exponents when we're raising a power to a power? Multiply them, so we just got x squared. Then I'm doing the thing that I don't enjoy, is when you go equals and then just add things. X squared, so I'm just looking at the top, we're kind of going through this to go, just ideas, what do we do with powers when we're multiplying and the bases are the same? Well, you add them, this to the 5, and we should have a decent idea of how to do it. Okay, this next one, how many terms we said, or we've done that one, right? So we said there were 2, so therefore we need to turn it into one term. Turn it. How do we turn multiple terms into one term? I always like to think of the idea of factorizing. Now, this isn't the be-all and end-all, but I like the idea of factorizing. And on the bottom, maybe just stick with the top. So here, it doesn't look like there's anything common, but there's Brendan. Yeah, so we've got square root 20, square root 20, remember, no calculators. That's the same as 2 square root 5 minus x square root 5. All of a sudden it looks like there's something common. There it is, by the way, the square root 5. So we can take that out as our common factor and hint switcheroo probably. Okay, next one, because I know this is cruising along, but we're going through a whole test just to see which strategy do we use when, because you're going to get to the exam and suddenly there's only 2 of these questions and you need to decide which strategy to use. So for this one, how many terms in the numerator? Just 1. How many terms in the denominator? Just 1. So therefore, what we want to do, I don't know, people say type 1, type 2 stuff, type 1, but I like always thinking, how many terms are there? Well, there's only 1 term, so we're not going to pull out a common factor or factorize. We're going to change them all to prime bases. So you want them all to be 2's because they all work out to be 2. So that's 2 squared, that's 2 cubed, and then you put that exponent on the top. And then you know how to do it because you multiply in, and this is 2 to the 4, and it's 2x plus 1. Multiply in, you've still got 1 term or 1 term, you've got 2 to the something over 2 to the something. What do you do with exponents when you're dividing and the bases are the same? Well, you subtract. So let's say that this was like 7, and let's scrap that equals, and that was 3. You go, 7 minus 3, that's 2 to the 4. So that's what you'll use when you get there. Cool. Man, it's like on a rush here. How many terms do we have in the numerator? 2, right? And we got 2 on the bottom. So therefore we start thinking, let's factorize or somehow change this, manipulate it such that we got 1 term over 1 term, because then we can start cancelling things off. So we've got our thing, so we go, well, common factor seems to come up quite often, and it does, not always, but common factor, maybe something doesn't stick out as a common factor. So therefore, for this we can say, well, let's split first. So sometimes people talk about split and factorize. So that is the same as 3 to the x, that's this first bit here. Let's get back to our colors, because if you were to multiply these, the bases are the same, so you'd add exponents, so that's splitting it, and therefore that's that part there. It becomes a bit more obvious that you've got some sort of common factor and go, let's take a 3 to the x out as our common factor, brackets, and then with a bit of luck, the 3 to the x's are probably going to cancel, and maybe even the brackets. But there's our strategy. Not working through the full question, you can do that. If you want to submit to some of yours and go, well, I got this far, now I'm not sure what to do, well, go for it. You've got access to the memo, you've done this test, we're seeing how to do it. Okay, question 2, and let's see, maybe we call it a day at that, because those are all those types of questions all in one where you're simplifying. So let's see